In this video, you will see Julian and Alyssa working on the following problem. The Mars rover is traveling along the Martian surface. The formula shows the rate at which dust accumulates on its solar panels along the 100-kilometer path. Will the rover accumulate 200 milligrams of dust? As they work, consider the obstacles they encounter and think about how you might solve the problem.
So I think how we want to do this would be like a Riemann sum. Yeah, so for Riemann sums, we're going to multiply the length of our intervals, whatever we decide that to be, times the value at those points of the interval.
Okay.
So what do you think are, I guess, so that's the length of each position interval. What should we have that be?
I guess like if we're going from 0 to 100, what if we just say our d is equal to 10?
Okay.
We'll set d equal to 10.
Okay, so I guess we could like try to draw these in.
So it would be like here down.
So that one's a left Riemann sum because we took the points.
I think like if you can see here, like we'll have like overestimates in this case. Okay, so in the chart, I guess we can, if it's like length 10, we can fill in like, yeah, we could do like this really quickly. So 10, 20.
So, and then, that's nice. So like these values are going to be like the area of the rectangles.
And then you were saying before about like this, like doing the Riemann sum, you would add up all the areas. So would you end up adding like these up? Like, is that what you're doing? Okay.
We can really type that in.
Okay.
So we want the sum from
1 to 10.
1 to 10 of. So this, with our overestimate, we get something that's like 230-ish.
It's bigger than 200.
So that would mean it wouldn't work.
But
then again, this is our overestimate.
So should we then try the right-hand side and see what our underestimate is?
Yeah.
Okay.
So that would be like ours. That would be like these. So we'd start from 10, go to 100. So I think that would mean these would go from 2 to 11.
And that's like significantly less.
Which I guess that doesn't really help us much because if our overestimate is over, like the rover might not make it. But then if our lower estimate is under, then that means like there's a chance that it could. Whereas if our lower estimate was over than 200, then that would mean like we know for sure it wouldn't work.
Yeah.
So I think we need to change. I mean, the only thing we have to change is our the intervals. So maybe if we make them smaller, maybe we can get a more then we can get a smaller interval.
Yeah.
So we can figure out where we're gonna be.
So like are you thinking like let's cut it in half, so we'll do like d equals 5?
Sure.
So if we're doing a left hand,
We want 20.
20,
And
and then the bottom will be 1.
Okay.
So our left hand, where it's still going to be an overestimate, is getting us a little closer to 200, but it's 213 now. Then what happens if we do?
And that's still under. So that's not going to work either.
So we're not really sure if it will make it or not.
Like we'd have to get something that's a lot more accurate than the intervals that we currently have.
In this video, Julian and Alyssa constructed left-hand Riemann sums and got approximations that were larger than 200 milligrams, but their right-hand Riemann sums were less than 200 milligrams, and they weren't sure how to get their answer that was precise enough. We'll explore the idea of making Riemann sums more precise in upcoming videos.